Application of differentiation, part 5. In this video, I would like to introduce how to find the obvious asymptotes. We have already discussed how to find the horizontal asymptotes and the vertical asymptotes. How about the oblique asymptotes? Please pay attention. If we find these conditions, then the vector function must have an oblique asymptote. What is this? What is the condition? When the degree of the numerator is exactly 1 more than the degree of the denominator, then that function, that curve, will have oblique asymptotes. Just like example 5.15. You can see the degree of the numerator is equal to 3, and then the degree of the denominator is equal to 2. That means this curve will have oblique asymptotes. So what can we do? How can we find the oblique asymptotes? Okay, we can consider make good use of the long divisions. Try to divide it. The dividend is equal to x to the power 3, and divisor is x squared minus 3x plus 5. Then, okay, this is x. So x to the power 3 and minus 3x squared plus 5x. Subtract it, 3x squared minus 5x. Okay, and then it's positive 3. So it's 3x squared minus 9x and then plus 15. So remember, you need to subtract it. This is equal to 4x and then minus 15. Okay, what is the application of these long divisions? I know the dividends must be equal to the divisor times quotient plus remainder. And I want to change the original functions. The numerator is our dividends, so I can change to divisor times quotients plus remainder. Then I can change the form. This two term divided by x squared minus 3x plus 5. I can separate them. So I do it step by step. So you can see we can cross out the denominator, and then remain x plus 3 plus 4x minus 15 over x squared minus 3x plus 5. What is the use of this simplifications? Now, y is equal to x plus 3 plus a rational function. You can find that this rational function, if x tends to infinity, if we take limit x tends to infinity, this term is equal to 0 because this is degree 1 and this is degree 2. So the oblique asymptote, when x tends to infinity, y will tend to this straight line. So the oblique asymptotes is equal to y is equal to x plus 3. Maybe you can pause the video and then do the following exercise 10. I will show you the solution, but you can pause the video first. If you want to find the oblique asymptotes, first of all, you need to observe, because the numerator is the degree of the numerator is greater than the degree of the denominator by 1. So I'm sure that this curve will have oblique asymptotes. And then do the long divisions. This is x, the numerator is your dividends, and then your divisor is x minus 3. After doing this step, I can change the form. It's x minus 3 times x plus 3 plus 10 divisor time quotient plus remainder is equal to our original difference. Okay, so same idea. You can simplify the form like this. When x tends to infinity, this term is equal to 0. So I know when x tends to infinity, y will tend to this straight line. Our conclusion, orbit asymptotes. This y is equal to x plus 3. That means this one.